Hey folks, welcome back to my thing, my Tetris thing. We'll start this off like we always do by playing a game of Tetris. So yeah, here we go. We are creating a Tetris data extractor because, whoops, I want to get better at this game. And every time I do one of these videos, I always mess up a lot. So you might think, what is this guy thinking that he's ever going to get good at this game? Well, I'm trying. Some very essential news though. On the Tetris front, I got myself a CRT monitor the other day. Whoops. And so I can start playing Tetris on a real CRT monitor like it was designed to, which makes this game a whole lot easier. With the LCD screen, there's a lag. With the controller adapter I'm using, there's a lag. And so when you get to when you're trying to move a piece over, in-game memory says it's already set down. So you have to be you have to play a very different way on an emulator on a computer rather than a CRT. And the real machines. Anyway, our job that we've tasked ourselves is to extract the data from this screen. And last time we were able to pick out individual characters and distinguish them from one another. So today we're going to build on that. And I hope that by the end of this hour, we are actually going to be able to say, what was my score? What was my my T-piece count? What was everything? And we're going to build up this object that we created in the first video to represent our data. So let's begin. All right. I also built a shelf to stabilize my camera, so that shouldn't be causing any more issues. Always making strides. And I got my coffee, and it's Saturday morning. Probably my favorite time of the week. Tetris data extractor. Come on, computer, let's go. All right, so if you recall last time, we made a series of unit tests. What is going on with my computer? I think every time OBS is running and capturing the display, it really bogs my computer down. All right, we created this iDigit interface, which will get us the string representation of a digit given a bitmap. And we created these tests where we had all these test images, one of each digit, and we ran them here. We pulled out the image and we recognized it, and we'll just keep ourselves sane by running these tests again. Half the life of a software developer is running unit tests again and again and again. So these tests will help us determine if we've made any mistakes or changed anything. Everything still checks out. We can still recognize each one of the digits. So now, I should have done this earlier. I don't know if I have. I think I've talked about this earlier. Okay. I am going to quickly install GIMP here, because we're going to use one. I was looking on the online, and GIMP actually has a nice feature, whoops, where you can draw a grid onto a picture. Well, you can see what I care about. Okay, that's going to download. Oh my word. just going to download in the background and we'll install it. So the plan today is to actually take a look at a big picture of a Tetris scene, and let's just remind ourselves what that looks like. It looks like these are all videos. Where's my... Oh, I think I've got to go into... Oh, this isn't a very exciting video anymore. Is it this one? No, it's not that one. Ah! Come on, RetroArch, where do you save your stuff? Okay, whatever. That's not what I want. App data roaming. There it is. Oh my word, screenshots. Here we go. Here's all my Tetris screenshots. Awesome. Okay. So there's an XY grid system to this thing, and we can go at the pixel level or we can go at the character level. These characters here, like these are all gray pixels up here. You know, these are black pixels, these are white pixels. But in old computer systems, you had these graphics modes where you could draw shapes, but if you were going to print text, it was still text. Like, there's a special grid system for the characters themselves, and I'm hoping, like, I don't know much about the Nintendo video card or how they really set things up. I'm just going from what I know about old computers. So we're just going to go with that assumption and create a grid system so we can look at each of these characters and hopefully it lines up, or else I'm not sure what to do. All right, looks like GIMP's downloaded. I'm going to install it now. Install for all users. Yes, let's go. Let's do this. GIMP takes a wonderful time to install. That's the stupidest splash screen for GIMP I've ever seen. Oh well. Okay, while that installs, we're going to take a look at our models, our classes here. So we have this Tetris data model, which we are going to populate. All the data on that screen that we care about. This is our digit reader that we made last time. And we have one public method that just says, get me the digit based on this bitmap. And this bitmap was just a small box that is that one digit. So this will be the heart of our engine, and as we move forward, as I move forward in my Tetris career, what's happening is that now I'm going to start playing on a CRT monitor or television, and I will split the video into my computer so I can actually stream what I do and take screenshots of my high scores and all that wonderful stuff. But what's going to happen is the image is not going to be so sharp and crisp. It's going to be a bit blurry. It's going to be a bit fuzzy because it's coming from a real Nintendo whose resolution, I think I determined before, it was like 256 by 200 or something ridiculously small. And that's being broadcast at probably 480 scan lines along the y-axis. So it's not a very high resolution, to say the least, and so the images will be blurry. And so we are going to change, when we come back to our system and we change it, we're going to probably only have to deal with this digit reader class to make it more forgiving for fuzziness. But we'll come to that when we get to it. Let's get the ideal situation working, where we have our screenshots from our emulators. Okay, so that's digit recognition. What we're going to do is we're going to make a folder here. Come on, add new folder. This will be called, we'll just call it screen recognition. This is going, you know what? Let's kill it. Again, naming things and changing our minds. We have a digit reader. Let's add a new folder. No, forget it. Forget it. Forget it. We'll do it the original way. Okay, this will be called screen reader. This is my screen reader. And we'll rename this again just because screen recognition. I want to use screen reader as the name of my class. But I can't have the folder the same name. Can't be the same name as the namespace. So we're going to make a new interface called iScreenReader. Okay, and this is going to be fine. This will be a public class. And looks like GIMP is installed, so we'll tell that to finish. Okay, so the screen reader is going to be our class that actually I want to basically give it a screenshot, and I want to say, hey screen reader, what's the digit at this XY location? Okay. So in order to do that, we're going to say should this really be an interface? Well, if it was an interface, I should probably call it an interface. But now that I'm thinking about it, let's just make it a class. We'll just make it a class because I want to use a constructor, and it's not like I'm going to be swapping out screen readers. So we are going to say, we're going to give this a bitmap. So this will be the screenshot. We're going to give it a screenshot. And we will save this into a private variable. Come on. Screenshot. And this will be read-only. You make it read-only so you don't accidentally modify it. We don't need to modify the screenshot. All we're doing is reading it. And so then we're going to save our screenshot. Okay, so now we can actually, we have this screenshot and we want to do a few things with it. So I want to have another public method, which is a string, and get digit at, and this will be an int x, int y. We better not say that. We better do this, row and column. The old computer systems used x, y coordinates for the actual pixel graphics. But when you're talking about text, it's rows and columns. And you specify the row first, followed by the column. So you deal with your vertical position, and then you deal with your horizontal position. And that's because the screen character system is laid out as a matrix. And in matrix mathematics, you define the element of a matrix first by its row and secondly by its column. That's my theory anyway, why it's done that way. So this public method is going to get us the character, or get the digit at this particular row and column. So in order to do that, we need to first know how many characters will fit along the width of the image, of the screen. How many characters? If we had our if we had text all across one row, how many characters would be there? And the thing is, I don't really know from looking at this. But that's why I installed GIMP, because we do know that our character boxes we made, if we go down to our test images, these were 45 by 39 pixels in this original image, which has been fit to the monitor size that I have. So the real digit in the Nintendo graphics is not 45 by 39, but this will all be relative to the screenshot that we had, so that it's going to be okay. First, I want to get this. Let's actually copy this. Let's make a new folder in our unit tests, because we will unit test the heck out of this thing too. And we're going to call this screen recognition. And in the digit recognition, we had to test images for our individual digits. Let's have some test images here as well. Let's add some tests. What was it? I can never remember. It was like app data, roaming, here, and I want all files. So somewhere in here is my personal best. Is it this one? No, it's not, but that's okay. This time I got 195,640. All right, so that's in there. I'm going to open this up with GIMP if I can. There's GIMP. I've never done this in GIMP before. I just read online you can. Just gonna make sure everything is looking good. I'm always nervous I'm not recording or something. Now, even when I say that, I am scared. Okay, GIMP, let's go. I swear my computer doesn't suck. Okay, here we go. We have this image in GIMP. That's fantastic. So now what I'm going to do is I want to make a grid. Now, where's this grid? I think it was view, show grid. Oh, this is perfect. Now, how do I change the grid size? Because this is not perfect. View. I found this the other day. How do you change the grid size? Because these look like... Oops, 1 second. I'm going to have to find the answer on the internets. GIMP. Editor, edit preferences. Oh my word. Choose default grid. Default grid. See, it's 10 by 10 right now. So 45 by 39. Let's do 45 by 39 and no, do not lock them. Okay, let's try this. Hey. Do I have to uncheck and then check it? Did I have to save something? What's going on? Default grid. Okay. Oh, come on. Image. Okay, what we're going to do is we're going to show the grid. Image. There's apparently... configure grid. Huh. Okay, 45, because that's not confusing at all. Okay, do not do that. 30, come on. 39. Not quite. Configure grid. Is that not what my size was? What was my size? (45 by 39). I might have to change this up then. 43. Let's go to 100%. Oh, this is not as lovely as I thought it would be. Image, configure grid. See, my looks like there's an offset going on. Oh, don't change them both at the same time. I think boy, that grid is not good. So then my question is this a grid at all? Here, let's make this white. I don't think it's a grid at all. But it is a grid. Look at that. The 41, oh. So it looks like the rows are okay. The columns are different sizes though. Let's get back to 0 on the... Oh, this is fascinating. This is not what I had in mind. But you can see that the rows are okay, 38 maybe. Interesting. Okay, cancel this, reset. Let's make it white, which it didn't make white. Well, this is fascinating. Because every character we were able to take and draw a box around just perfectly. Whoops, come on. That's our 45 by 39 box. So it looks like we have, if I line up the score, that all lines up beautifully. The line count lines up. The level kind of. So I think this might be an issue with certain, like just one pixel off. This is not a very exciting video. Oh, this is what we do. See, that's not quite it either. Whoops. What? Whoops. Reset. Shoot. Why does it never... So the level 16 they are the same size. They're just not, yeah, so the same box around them. But then if I line up these aren't quite lined up. These aren't quite lined up, and these are really not lined up. Okay. But let's 1, 2, 3, 4, 5, 6. 45. I think it was 1411. Let's take a look at my calculator here. 1411. That was the width of my image divided by 45 equals 31. Okay, so then if I had the Nintendo resolution, 256 by 240. So 256 divided by 31 is 8.25. Well, 256 divided by 32 is a nice even 8. It's probably what it is. I'm thinking you can fit 32 characters across, 8 characters wide. This is 256 characters wide originally, thus saith the Nintendo. My image is 1411. So I have to take that 8 and multiply it by 5.5 to get a 44.09375. 44.09375. Sure. And then my height. My height is 1080 because that's my monitor. So what I'm going to do is how many... Let's go back to the original. 1080 divided by 39 is approximately, oh boy, 27 point some odd. So that's about how many rows on the original. So the original is 240. Wait a second, what was that again? 1080 divided by 39. Okay, 27. So we've actually got 240 divided by 27. No, this should be divided by 29. Not quite either. Although that's... Yeah, we're just going to have to make it 30. Which again is 8. So that kind of helps me out. Then 1080, 240, no, so there were 30, yeah, so I can go 1080 divided by 30, and that's 36. So, okay, let's try a 36 here, see what that does. And then I don't really need to offset it. I don't want to offset it. Oh, you guys, this is looking awesome. No, it's not. Not quite, eh? Oh gosh, this is a bit annoying. That's okay. That's okay. This is just going to take a little bit more thought. How can we do this? How can we do this? Because this is no longer... The image capabilities and the graphic system of the Nintendo is obviously something I don't know. Well, I could have told you that. But it seems like the score... If I make this 45... I think what we're... Oh, boy. I think what we're going to do... Say, you know, to heck with this. We're going to find exact pixel placements. So we know that our characters are 45 by 39 in our nice modern image. I thought I could create a grid system which would make it easier to say, hey, give me the digit at this row and column. But the rows and the columns don't quite, they're not quite as spaced as I thought, because the score is pretty good, the level is pretty good, but look at this next. It's right in the middle. And look at these piece counts. They're like right in the middle, except this one's pretty good. This one is... So I just went and made that 45 too. Yeah, it's just not quite as good. So that's okay. What we're going to say then is we're going to find a pixel value, and we're going to say, get me the 3 digits at this location, at this starting location. And that's what we're going to do. Then I can say, hey, look, here's my pixel. Get me the 6 digits of my score. Here's my pixel. Get me the 2 digits of my level. Here's this pixel. Get me the 3 digits of my piece count. That's what we're going to do. I think that's probably the best thing. Okay, that was a unfortunate thing that occurred, but that's okay. We're going to change our code then to instead of, oh, this is not called iScreenReader, this is called ScreenReader. Instead of giving a row and a column, we're going to be giving it a pixel, X, Y, and then a number of digits after that. Okay, and we're going to set some private variables here, some constants. X width equals 45. This is an integer. And constant Y height equals 39 was what we had done our tests with. Constant ints just tells the compiler that these are constant values. You can't reassign them to anything else. It's just like the number 45 was appearing everywhere. Okay, then we're going to give the number of digits. Now the algorithm for this is we need a sub-image. So sub-image equals screenshot. And screenshot gets us, we're allowed to size, width. I thought we were allowed to make a new, maybe we can make a new one, a new bitmap from the original screenshot. Because what I want to do is I want to crop this image. Maybe I don't have to. We can just loop through. Okay, so X, the start X equals X, start Y equals Y. No, what am I saying? This is silliness. This is silliness, folks. I need to get the bitmap. Okay, one more time to the internets. Bitmap crop image. Oh, interesting. Sorry about the sound in the background. Someone is doing some construction work. Okay, so I need to crop this image, and I do it by creating a rectangle, because that's a thing. And this rectangle is going to define the width and the height. So we're going to say var crop area. No. Crop area equals new rectangle. And we're going to make this starting at new point xy. Okay. New size. What is this? In width and height. So the width of our rectangle is going to be num digits times x width, because that's the number of digits. Each digit is 45 pixels wide. This is the size of our rectangle we're going to use to crop it. And then the height will always just be y height. That's the crop area. Then I can go sub image equals, I can say screenshot dot clone, apparently, and I'm just looking on the internets here. So clone will create a new copy of the image, but I can say, hey, give me one with just this cropped area. Pixel format, what is this? Okay, so this is just some pixel information, and I can say, tell it to use the pixel format of the original image. So theoretically, this gets me the image of the digits that I want. Okay, that's my sub image. See, I want to use my digit recognition, but my digit reader takes in a bitmap of a single digit. So that's actually the only thing I need to create. Anyway, I've created the sub image. Now I'm going to go for int let's say row equals x. Row is no, I want to start at x, but I want it to be relative. My starting position, I want it to be 0. So we'll say column. The first digit in the column of the rectangle I'm looking at equals 0. Column is less than num digits. And the column is going to be increased by the x width. Okay. Then I can say, I want to say var digit image equals sub image dot clone, and I'm going to make a new rectangle. So actually, let's digit crop equals new rectangle. This is a new point, and this is going to be the actual point of the sub image. So the x coordinate is going to be column times x width. The y coordinate will be 0. The size is going to be just the width of a single digit and the height of a single digit. That's it. Okay, and then I can say Well, I think for debugging purposes, we'll say we'll assign this to a new variable. So digit image equals the sub image crop, and I'm going to say digit crop and sub image dot pixel format. So now digit image is a bitmap. Hey. Oh, not crop. Clone. Okay, so digit image is now a bitmap of a single digit, and now I can say, here I'm going to have my number, final number equals, and again there's strings because I'm just going to concatenate them. Oh, but actually this doesn't have to be. I can make this an integer now. Get, I'm going to change this to get number. Get value at, and so the final number will be a string because I'm going to be concatenating them together. So then var digit equals, now I need an instance of my private read-only of my character recognition, and this is where it comes in. I digit reader, and if I was doing some inversion of control, I'd bring it in as a dependency, but for now we will just make a new digit reader. It doesn't take any parameters at all. There it is. It doesn't have a constructor. It's got a default constructor, so it's fine. Everything okay here? Yeah. Actually, how long have I been recording? We've been recording for 47 minutes. Our hour is almost up. Screen reader. Okay, so here we have a new digit reader, and I can use it now. Var digit equals digit reader dot get digit. I'm going to pass it the digit image. Okay. Now, obviously, something could go wrong. Something could go very wrong. So we're actually going to throw this into a giant try-catch. This is not something I want to have in the final version. Actually, we don't have to. We'll just be debugging it for now. The problem with try-catches is that they're very inefficient, and it's just like a catch-all bag. If you really want to understand what can go wrong with your program, if your only error handling is just catch any and all errors and throw a message, that doesn't really help you understand what's wrong with your program. So I'm not even going to put a try-catch in there. If something fails, we'll see it in debugging, and our tests won't pass, and all that stuff. They have their place, try-catch blocks, but I'd rather not use them. Okay, so var digit. Now digit is a string. It's a representation. So I'm going to say final number plus equals digit. And when you add two strings together, it just gets concatenated together. So this is going to build up our digit, our number. Okay, and then when we're done, we can say return int.parse final number. And int.parse will parse a string, look at it, and turn it into an actual number. Okay, folks. Yeah. Now the issue is we have to get our pixel value correct, which might be a bit difficult. So anyway, Let's try this out. And the way we're going to try this out, I'm going to rename this image to test. We're just going to call it screenshot 1. We are going to make a test, and this will be called Screen Reader Tests. And we're going to make this a test class. Yes. Okay, how did I do this before? Oh yeah, I did that way. Okay. So let's do this. I'm very curious if this is going to work. Again, and my apologies for that saw. I don't think he knows we're filming right now. New screen reader. See, and now the screen reader needs oh, that's right. I can't. Wait a second. Screen reader doesn't take just a bitmap. Oh yes, it does, because it uses the digit reader in there. Yeah, and that's why. So for unit testing, we're going to come back next time. We're going to turn this into a dependency so we can fake it out. Well, actually at the same time, no, we do need to fake it out. If we're going to do this for real, we're going to need to fake it out in our tests. Anyway, but for now, since we're almost at the hour, I want to just see this work. This would be so cool if this worked. So we actually can't do this because we make a new instance for every. Let's do this. Get value at works. We're just going to say it works. So the image equals. Can't remember how we created images. Oh, we just give it a new bitmap. Okay. New bitmap. And then the file name is going to be testimages/screenshot1.png. Okay, and then we are going to say SUT, the system under test, is a new screen reader for the image. Okay, so now that we have that, we're going to say var score. Let's get the score equals sut.getValue at. Now we need x, y values and a number of digits. Well, good thing I've got GIMP here. What did I just do? Discard changes, please. Of course. Because I renamed it. Okay. Open with. GIMP should be there. Wow, I wonder what he's doing. That's really loud. Okay, here it is in all our glory. Let's get these 6 characters here. Now, if I say like this pixel here, which is 1057.268. 1057.268. Let's try it out. 1057.268. Get me my 6 digits. Score should be, what should it be? What is it? 195640. And that is no longer a string. That is a real number. So folks, I don't expect this to work right out of the box, but we can hope. We can hope, can't we? Here we go. Oh, I need to run the test, not run the program. Okay, let's debug this. We're going to see this every step of the way. Okay, we'll step over this, just make sure. Oh, parameter is not valid. Oh. I didn't make this copy over. Now it should work. Okay, let's do this again. The file is in your code, but it's not in the output directory, so it doesn't know how to find it. Oh, come on, parameter's not valid. Okay, this is okay. I have the same setup in my unit tests. Here. Oh, I have to go screen recognition test images. My bad. Screen recognition / test images. Okay. Now this will work. As I just said, 3 minutes ago, that's not going to work. Perfect. So here's my image. It is a big image, 1411 by 1080. And the pixel format, that's what we were looking at before. It's 24 BPP RGB. Okay, fine, great. Let's make the new screen reader. That's okay. Okay, I could just run this, but I want to actually see if this works. So let's do this. I want to step through it one at a time and see everything happen. So the crop area, the width is 270. That's because I'm getting 6 digits at 45 pixels wide each. Okay, I'm going to take, now the clone I've never run before, but that looks like it worked. The size is 270 by 39. Okay, the final number will start out at here. We can actually pin this. Here's the final number. We're going to see this build up. Okay, column. Let's actually throw column up there too. Column is 0. Num digits is 6. So here we go, digit crop. So the digit crop should be 45 by 39, and it is. That's good. The digit image is now the image, which is 45 by 39. Now we're going to send that into our digit reader. Oh, and we couldn't find it. I couldn't verify what the digit was based on the fingerprint 70.71. Look at that. Ones need to be 70.99. I wonder. It means I lost a pixel or two. Maybe my maybe I should be down here at like my Y should be, what did I have, 1057 before? Here, let's not do that. Let's say 1061. Actually, I can draw Come on. 45 by 39. That's the box I'm drawing. So this is kind of the box I want to draw. There. 1056. Is that's 1056 270. 1055. I wonder if I've lost something. I'm going to tweak it a little bit. I'm very close to the 1 though. You can see that. I'm very close to the 1. We could make it fuzzy, I suppose. Get value at 268. You know, let's make it 270 and 1056. We're going to take away this debug, but I do want to go in here and stop right there. Let's go back here and debug this. Okay, we have our things here. Let's 70.71. That is so odd. It's like I'm missing. Is that number 1 any different? I don't know. Maybe I should bring it up a 1. I mean, all 1s are the same. Come on. Okay, I'm going to bring it up one more time. We'll see if we get a... But see, I moved that box a little bit and I still got the exact same thing. Yeah, this one clocks in at 70.9. I wonder what the difference is. We'll just run it. We won't debug it. Based on the fingerprint 70 point. Okay, you know what we're going to do? I'm going to hack it. I'm going to... It clearly thinks the fingerprint should be something different, which is ever so slightly. So what I'm going to do... We are going to have to figure this out, but I just want to see this get past the number 1. So I've hacked the fingerprint. You can see it's only a 0.2 difference. Okay. And this actually gets me thinking about what's going to happen when we go to a real Nintendo screenshot. I think what I'm going to do is I'm going to take an ideal image and overlay it the actual image, and we'll count how many pixels they have in common. And then I'll create a probability chart to say this is a digit, which one does it best match? And that's how we'll get our digit. I'm pretty sure that's how we'll go in the future, but for now I just want this to work. Okay, so let's Let's debug it. I want to see this actually recognize the 1. It is going to recognize the 1 because I hacked it. I mean, there's no question about it. So there it is. It figured it out. It was a 1. So then we're going to add it to final number. And you'll see up here, final number is now 1. We'll go up here. Column is now 45. Oh, shoot. Column is less than num digits. No, column needs to be less than num digits times x width. Oh, hold on. No. Column just needs to... We just need to add 1 to column because we're multiplying it by x width here. Let's get rid of this. Okay, now we're good. Now we debug it. Am I over the hour? Ladies and gentlemen, we are over the hour. So let's watch final number build up. There's a 1. Column is now 1. It couldn't verify what the digit was based on the fingerprint 59.08. Oh, man. Seriously. 59.08. And this is a what? What is the actual digit? I would have pegged it as a 5. 59.08. It's closer to a 5. What is going on? I wish... Okay, I think we're going to stop it. We didn't get very far this time. We sort of have an idea of how we want to use the digit recognition, but it's not quite working out. I think the next step is to find a way to we will save the images, the sub images, so we can have a look at them and see what the heck is different about our canonical digits that we use in the tests. So yeah, you know what? It's okay. I think we're on the right track. We just have to hash through this a little bit. We will get there. So yeah, thanks for joining me. Have a great day, and we'll see you next time.